Hi, folks, welcome back. I hope you're all doing well. Today, I want to get out of my comfort zone in computer science for a little bit and look at an economics paper. The title of this paper is Testing the Automation Revolution Hypothesis. And what it tries to do is look at some data to see what factors might be predictive of automation in US jobs, and they get data that covers the period from 1999 to 2019. So they have 20 years worth of data, which is pretty significant. So let's see what they found. The background that motivates this paper is that in the last few years, there have been an increasing number of claims that we are getting into an automation revolution that is going to destroy a lot of jobs at an increasing rate. The author cites some examples like Fortune claiming that 40% of the world's jobs will be lost to automation in the next 15 years, or claims that AI will surpass human intelligence in the next decade, or that a quarter of all American jobs would be lost to automation in the next 10 years. And this goes on and on. Surely, if you've read a newspaper in the last 10 years, you've seen one of these headlines as well. What the authors are doing in this paper is trying to test all these claims with data. And the data they use is about 1,500 expert reports that talk about the degree of automation of more than 800 US job types over a period of 20 years, 99 to 2019. And they use this data to see what factors are predictive of automation and how automation and levels of automation have changed over these last 2 decades. Their main data source comes from ONET, which is a database of US job features. This is a database which, for every job type, lists out features that are relevant to that job. And this data comes from experts as well as employees in those job categories. For example, some of the features could be years of education, or thinking creatively, or indoors environmentally controlled, which describe the various kinds of things that are important for that kind of job, or that describe the environment that the job is carried out in. One of the main ONET job features is something called degree of automation, and this goes from not at all to completely. Of course, the caveat is that all these features are reported by humans on a qualitative basis. And then they take this ONET job feature data and combine it with US employment statistics. And their third data source is expert derived metrics of how vulnerable a particular job is to automation. They call these metrics computerizable and machine learning suitability. And then they feed all this data and try to create a linear interpolation model and a regression model where automation is the dependent variable. So, what did they find? They found that the strongest predictor for automation is a job feature called pace determined by speed of equipment. And for that feature, one standard deviation change in it predicts almost a zero point 0.6 standard deviation change in automation level, which is a huge correlation. The next most important predictor is called the importance of repeating the same tasks, which has a smaller but still significant coefficient of about zero point 0.2. And at an intuitive level, this makes sense because if your pace is determined by the speed of equipment around you, that means you're in a kind of assembly line setting where your job is working very closely with machinery. The other factor, which is importance of repeating the same tasks, again picks out jobs which have many similar and independent small tasks. Now, one big caveat in this data is that these job automation scores are coming from subjective judgments by humans. And it just might happen that over time, the meanings of these terms might shift. The meaning of what it is to be slightly automated versus highly automated might shift over time. So that's something we have to keep in mind. Another important finding is how the suitability of jobs for automation has changed over this period. And they found about a 0.37 standard deviation change over this period. They propose a theory of how automation proceeds through a cluster of connected jobs. So if you have one job that is highly automated, that makes it much more likely that other jobs that interface very tightly with that automated job are also going to get automated over time. One somewhat surprising thing they found was that increases in education levels predict declines in pay and employment, even though the coefficient was pretty small. They posit that this might happen because if there is a labor shortage in a field, firms working in that field tend to reduce their education requirements. You can definitely see this happening in programming and software development, where a CS degree or a software engineering degree is not a requirement for getting a job as a programmer. And many programmers go to boot camps or are self taught. So, on the whole, the authors are not finding a ton of evidence that are consistent with all the alarmist headlines that we have been seeing about automation destroying a huge fraction of jobs. What they find is that reported automation levels have stayed more or less stable, with the caveat that some reporting or linguistic standards could mask some of these increases. Also, jobs that did get automated to a large degree on average did not see huge changes in pay or employment. And most significantly, the factors that correlate with employment, things like the pace of work being dictated by machines or working on many similar tasks, these factors have not noticeably changed in the last 20 years. So, yes, automation is a trend, and automation is changing many jobs. But what the authors here find is that over the last 20 years, there has been no huge acceleration in that trend. As they say, they do not find support for claims that we are in the midst of a trend deviating revolution for job automation. So that was a quick look at a paper that looks at some data for how automation has influenced jobs over the last 2 decades. I hope you enjoyed that, and I will see you next time. Thank you very much.